Trigonometric equations. What is a trigonometric equation? An equation containing the trigonometric ratios of an unknown angle is called trigonometric equation. There are three things to understand. A trigonometric equation is an equation. Number one, to remember, it is an equation containing the trigonometric ratios. The second point to remember is it contains trigonometric ratios, and the third thing to remember is an unknown angle. So what's an equation? An equation always contains equal sign, eq equal sign. Okay. And what are trigonometric ratios? Trigonometric ratios are sine, cos, tan, cosec, sec, cot. And an unknown angle can be denoted by Greek alphabets alpha, beta, gamma, theta, and so on. It can also be denoted by the English alphabets A, B, C up to Z. Okay, so let's take an example. One of the example of trigonometric equation is sine theta equals to root under 3 by 2. Now let's check it out whether it is a trigonometric equation or not. First, it must be an equation. It means there must be an equal sign. See, here is an equal sign. Second, there must be a trigonometric ratios. Sine, cos, tan, cosec, sec, cot. Either there must be at least one trigonometric ratios. Okay, at least one. So here we have sine. It is a trigonometric ratios, and there is one unknown angle theta. Its value can be anything. Okay, here theta, it's an unknown angle. So it satisfies all the conditions for the definition of trigonometric ratios. So sine theta equals root under 3 by 2 is our trigonometric equation. Similarly, let's take another example. Example number 2. Cos theta equals to 1 by 2. It is also a trigonometric equation. Number 1, here we have equal to sign. Number 2, we have a trigonometric ratio, and number 3, there is an unknown angle. So it is a trigonometric ratio. In the same way, let me take one more example. Number 3, 4 sine square theta plus 3 cos theta equals to minus 3. It is also an example of trigonometric equation. So three conditions. Number 1, it must be an equation which is denoted by equal to sign. So we have here equal to sign. The second is there must be a trigonometric ratios. Here we have two trigonometric ratios. One is sine, the other is cos. And the third one, there must be an unknown angle. See, here theta is an unknown angle. So it is a trigonometric ratio. Okay. Now, to understand the trigonometric ratios or to solve the questions related to trigonometric ratios, we need to understand certain terms, certain conditions, or certain formulas. Okay, so suppose this is x-axis and the vertical line is y-axis. Yeah. On the right side we have x, on the left side we have x dash, on the uppermost side it is y, and the down side it is y dash. The meeting point of x-axis and y-axis is 0. On the right we have positive x, 1 2 3 4 5. The upper one is positive y, 1 2 3 4, and the left side is negative x, -1 -2 -3 -4. In the same way, the down part is negative y. Okay, if we suppose this x-axis at 0 degree, okay, then y-axis denote 90 degree. From x to y it is 90 degree, and from x to x dash it is 180 degree. So this line denotes 180 degree. In the same way, from x to negative y it is 270 degree, and from x to x a complete rotation makes it 360 degree. So each interval here is a 90 degree. So in the same way, Again, if we continue with 90 degree also becomes 400, 50 degree, 180 degree becomes uh, 500, 40 degree it is 600, 30 degree, and it goes on like this. Okay, now what we need to understand here is from 0 to 90 degree, 0 degree to 90 degree, it's called first quadrant. 90 to 180, 90 degree to 180 degree, it's called second quadrant. Okay, and from 180 to 270, it's called 180 to 270, it's called third quadrant, and 270 to 360, from 270 degree to 360 degree, it's called fourth quadrant. Now what we need to understand here is if the unknown angles, if the unknown angles comes in first quadrant, that means 0 to 90, all the trigonometric ratios are positive. Okay, in the same way, if the trigonometric ratios, if the unknown angle of the trigonometric ratios falls in second quadrant, that is 90 to 180 degree, okay, sine and cosec will be positive, remaining cos, sec, tan, cot becomes negative. Okay, in the same way, the value of unknown angle of any angle of trigonometric ratios in third quadrant, that is 180 to 70, here tan, the value of tan and cot becomes positive, remaining sine, cosec, tan, cot, sorry, sine, cosec and cos, sec, the value becomes negative. And in the fourth quadrant, from 270 degree to 360 degree, the value of cos and sec will be positive, and sine, cosec, tan, cot, it will be negative. Okay, this is the one thing, this is one of the matter to remember. Now second, sine 90 degree minus theta will be equals to cos theta, cos 90 degree minus theta will be equal to sin theta. In the angle of 90 degree minus theta, tan 90 degree minus theta will be cot theta, cot 90 degree minus theta will be equal to tan theta. Similarly, sec 90 degree minus theta will be equal to cosec theta, and cosec 90 degree minus theta is equal to sec theta. Okay, in 90 degree, see all the angles are 90. In 90 degree, sin changes to cos, cos changes to sin, tan changes to cot, cot changes to tan, sec changes to cosec, and cosec changes to sec. Okay, it happens in 90 degree and odd multiples of 90 degree. It means 90 degree into 3 to 70 degree, 90 degree into 5, 400, 50 degree, and so on. All these change in trigonometric ratios occurs when there is 90 degree or odd multiples of 90 degree. Okay, and see all the values of trigonometric ratios are positive because 90 degree minus theta, it falls in first quadrant. Okay, in the same way, now what if the angle is 90 degree plus theta? Sin 90 plus theta will be equal to cos theta. Why? Because since here is 90 degrees, sin becomes cos. Here we have the angle theta, and 90 plus theta, the whole angle goes to second quadrant. In second quadrant, the value of sin is positive, so here we have positive. So sin 90 plus theta will be cos theta. But cos 90 degree plus theta will be equal to minus sin theta. Why? Because of 90, cos changes to sin. Here we have angle theta, and 90 plus theta goes in second quadrant, so the value of cos in second quadrant is negative, so we have the negative sign over here. In the same way, tan 90 degree plus theta is equal to minus cot theta, and cot 90 degree plus theta will be equal to minus tan theta. Why there is a change? Because of 90 degree angle is same as it is, and 90 plus theta, it goes in second quadrant. Tan cot both are negative, so we have negative sign over here. Okay. Now same goes for second cosec as well. Now what if the angle is 180 degree minus theta or 180 degree plus theta? Let's check it out. So let's start with 180 minus theta. Sin 180 degree minus theta will be equal to cos theta. Why? Here 180 degree is the even multiple of 90 degree. Remember that. If there is the odd multiple of 90 degree, then the trigonometric ratios change. Okay. 90 times 3 is 270 degree. 90 times 5 is 450 degree. In the odd multiples of 90 degree, trigonometric ratios change. But in the even multiples of 90 degree, trigonometric ratios do not change. In 180 degree, ratio do not change. In 360 degree, trigonometric ratios do not change. In 540 degree, trigonometric ratios do not change. So the conclusion is, if we have the odd multiple of 90 degree, trigonometric ratio change. If we have even multiple of 90 degree, trigonometric ratios do not change. Okay. Now since 180 degree is the even multiple, sine becomes sine, and we have theta over here. 180 minus theta, it goes in second quadrant. In second quadrant, sine is positive, so sine 180 minus theta will be equal to sine theta. Similarly, cos 180 minus theta will be equal to minus cos theta. 180 degree is the even multiple, so cos becomes cos. 180 degree minus theta is in second quadrant, so the value of cos is negative, so we have here minus cos. In the same way, it goes for tan, cot, sec and cosec as well. So what is the main thing to remember? The main thing to remember is, if there is the odd multiple of 90 degree, trigonometric ratios change, and if there is the even multiple of 90 degree, then trigonometric ratios do not change. Trigonometric ratios do not change. Okay. And for the sign, for the value positive and negative, we should see the quadrant. We should see the angle, whether the angle lies in the respective quadrant or not. And there is one thing to remember, one more important thing. For the negative value of cos, the value of cos will be positive. Cos minus theta will be equal to cos theta, and sec minus theta will also be equal to sec theta. This is for cos and sec only, for cos and sec being the even function. Okay. नेक्स्ट भिडियोबाट चाहिँ म एक्सर्साइजको क्वेसन्सहरू सल्भ गर्न सुरु गर्छु।